Hello students, I am Subhajit, your chemistry mentor for NEET and JEE. Today we are going to discuss Bohr's atomic model. So before that we have already learned about the Rutherford's atomic model. But there is a limitation or demerit in case of Rutherford's atomic model. Rutherford atomic model failed to explain the stability of an atom. Then Bohr tried to explain the stability and he put forward a new atomic model which is known as Bohr's atomic model, and it is based on the Planck's quantum theory. So today we will discuss about that. There are three postulates in Bohr's atomic model. First postulate tells that electrons are revolving around the nucleus. Here this is nucleus and these are the electrons which are revolving around the nucleus in different orbit. But Bohr specifies that electron cannot revolve in any of the paths. There are some particular paths or fixed paths in which electron can revolve, and these fixed paths have fixed radii, and these permissible values of these radii will be such that angular momentum of the electron, that is mvr, here m is the mass of the electron, v is the velocity of the electron, and r is the radius of the electron. So mvr, that is the angular momentum of the electron, is directly proportional to h by 2 pi, or we can say that mvr, that is angular momentum of the electron, will be the integral multiple of h by 2 pi. So mvr will be equal to integral multiple, that means value of n will be integer. So here value of n will be 1, 2, 3 and so on. This is the first postulate. Second postulate of the Bohr's atomic model tells that electrons, while revolving in such fixed orbit, neither absorbs energy nor emits energy. That means energy of the electrons in these orbits or cells will remain constant while revolving. That's why these paths or orbits will be called stationary orbits. So here we are getting the concept of stationary orbits. That means energy of the electron in such orbits will remain constant. The third postulate of the Bohr's atomic model it is discussed that electron, when jumps from lower energy level to higher energy level, so the inner orbits are the lower energy level and the outer orbits are higher energy levels. So when one electron jumps from lower energy level to the higher energy level, it absorbs some energy, and when an electron jumps from higher energy level to lower energy level, it emits some energy, and this energy is available in form of waves. So say for example, energy of this cell is E1 and energy of the higher energy level is E2. So the energy difference delta E equals to E2 minus of E1. This energy difference according to the Planck's quantum theory is directly proportional to the frequency of the wave. So according to the Planck's quantum theory, delta E energy equals to h nu. Here h equals to Planck's constant. So this is Bohr's atomic model, and these are the three important postulates of Bohr's atomic model, and from these postulates we can calculate the radius of a particular orbit, velocity of the electron revolving in such orbits, energy of the electron in the orbits. So now we will move towards the calculation part, that is the calculation of radius of orbit, velocity of the electron as well as energy. So from the first postulate we have got this formula, mvr equals to nh by 2 pi. When one electron is revolving in an orbit, it feels two kind of force. One is centripetal force, another one is centrifugal force. Centripetal force is the attractive force towards the nucleus or the center, that is centripetal force, that is nothing but the Coulombic attractive force between nucleus and electron. If we assume the charge of one electron is E, then charge of the nucleus will be Ze. Here Z is the proton number, or we can say the atomic number. So the centripetal force will be equal to Z E square divided by R square. Here R is the radius of the orbit, and there is also another force which is centrifugal force, which will be towards the outside or opposite to the centripetal force, and this centrifugal force will be equal to m v square divided by r. Now these two forces balance each other, so we can write z e square by r square equals to m v square by r. So here we can write r v square equals to z e square divided by mr. Okay. Now we have already got mvr equals to nh by 2 pi. So we can write v equals to nh by 2 pi mr, or we can write v square equals to n square h square divided by 4 pi square m square r square. Here v square equals to z square by mr. So if we put the value of v square here, we will get z square divided by mr equals to n square h square divided by 4 pi square m square r square. So now 1m 1r. So from this equation we can get the value of radius r equals to n square h square divided by 4 pi square m z square. So we can say that radius of the nth orbit is directly proportional to the cell number to the power 2. So r is directly proportional to n square. So from the above equation v equals to nh by 2 pi mr, if we put the value of r in this equation, we will get the expression for velocity of the electron. So now we will put the value of r here. So here v equals to nh by 2 pi mr. So we are getting here the expression for r. We will put this value nh divided by 2 pi m into 4 pi square m z square divided by n square h square. If we simplify this equation, we will get 2 pi z square divided by nh. So from this equation we can write velocity of the electron is inversely proportional to the cell number. So v is inversely proportional to n. So this is how we can calculate the velocity of the electron and radius of the orbit from Bohr's atomic model.